We're going to do more derivatives. We haven't learned all the derivatives yet. Okay. 4-3. Let's do a little warm-up first to just kind of get your calculus brain juices flowing. So today we're going to do derivatives of inverse trig functions. There's a couple of ways to do these inverse trig functions. You can either memorize a bunch of stuff, which I'm terrible at memorizing, so I don't like to do it that way. I'm going to teach you how to do it by implicit differentiation. Now let's remember what implicit differentiation is real quick, okay? So let's say that you have, here's just a little warm-up. Let's do xy plus the sine of y is equal to 15. And let's find the derivative of that, okay? Let's see if we remember how to find the derivative of that. All right,
so remember, you have to do x times y.
Product rule. Okay, so we're going to start with doing product rule of the x and the y, okay? So we're going to go a times b prime plus b times a prime. Okay, so that's the derivative of xy plus the derivative of sine y, yes, is cosine y, y prime.
Cosine y,
Mm-hmm. You have to take, it's chain rule, remember? You have to take the derivative of the sine of y, which is cosine y, and then you have to take the derivative of y, which is y prime. And the derivative of 15 is 0. Okay, now let's get all of our y primes together. So I have xy prime plus cosine y, y prime equals negative y. This is y times 1 is y. I subtracted it to the other side. Let's go ahead and factor out a y prime to get x plus cosine y equals negative y. So y prime is negative y over x plus cosine y. And that would be the derivative. So we used product rule and we used implicit differentiation there. All right, we're going to do product rule and implicit differentiation on the ones today. So let's go ahead and try the one, like one of the new ones, all right? So here we go. Number 1, find the derivative of these inverse trig functions. Do you remember what an inverse trig function is? All right, let's have this. Y equals sine inverse of 3x squared. Another way that you wrote these was arc sine. Do you remember arc sine? Yeah. These were really bad. Like this whole lesson was a bad lesson. Okay, there's a way to memorize it if you want to. I just don't like it because I can't remember them. So this is the way I like to do these. Not everybody does them this way, so if you go to college and you end up doing these again, they might do them a totally different way. What I like to do is I like to take the sine of both sides, okay, so that I get sine of y equals 3x squared. Sine y equals 3x squared. And now I like to take the derivative of both sides, okay? So the derivative of sine y is, we just did this, cosine y, y prime, equals, the derivative of 3x squared is, oh yeah, why did I write a 9? 3 times 2 is 6x, okay? And then y prime is equal to 6x over cosine y. But there's a little bit of a problem. They're not going to let you leave your answer in terms of y. Okay? So what you need to do is you have to set up a triangle. Let me show you. We set up a triangle. Ew, that's gross. And we call this y. This angle is y. It's a right triangle. Okay? And if you look at this, it says here that the sine of y is 3x squared. Okay? So the sine of this y is 3x squared. Well, sine is opposite over hypotenuse. So that means that this would be 3x squared and this would be 1. Okay? So now what I need to do is at the very end, this part, I need to find out what the cosine of y is in terms of x. Okay, so what would the cosine of y be? Cosine is adjacent over hypotenuse. So I need to find out what this side is right here. What is that side? Well, you're going to use Pythagorean Theorem, right? It would be a squared plus b squared equals c squared for that side. And however you want to do that is fine. So let's say a squared plus 9x to the 4th equals 1. You see what I did?
Yep.
This is a. So a squared plus b squared equals c squared. So what would a equal? A would equal the square root of 1 minus 9x to the 4th. So what would the cosine of y be? Cosine of y would be adjacent over hypotenuse. So it's 1 minus 9x to the 4th. And so then my final answer would be 6x over the square root of 1 minus 9x to the 4th. And that would be the derivative. That's a lot of work, huh? Now the other way is just to memorize the formula. Do you want to know that way? Yeah? Let me just show you real quick. If you have y equals the sine inverse of u, okay, then the derivative of this is going to be 1 over the square root of 1 minus u squared and then times u prime because it's chain rule. Okay? Do you see how it's going to be the same thing? But who wants to memorize all of that?
So it's u prime over square root of 1 minus
Yeah.
u squared.
Uh-huh. So this would be like saying this is u, 3x squared. So u prime is 6x. And then it's 1 over the square root of 1 minus 3x squared squared. Should be that. I don't like that, though. I don't like to memorize. It's like a whole bunch of them. Look at all of them. There are all of those. You want to memorize all that?
It's the same for each.
These are opposites. Those are
Oh.
opposites. And those are opposites. So yeah, I
So
guess
you
if
just
you
memorize
memorize
the ones
sine,
That the inverse
And cosecant.
yeah, then you would be fine. Yeah. I don't know. Okay, let's try another one. Another one. Number 2. Okay, y equals tan inverse of the square root of x plus 5. This one's going to be tricky. Okay, so let's first start by,
X plus 5 to the 1/2. No,
wait,
right?
we got to tan both sides. In the summertime, make sure you flip halfway. All right, tan y equals, does anyone tan anymore? You guys know that's bad for you. It's really bad. It causes wrinkles. Tan y equals the square root of x plus 5. But you're right about that x plus 5 to the 1/2. We are going to do that. All right, so now we want to take the derivative. And do you remember what the derivative of tangent is? Secant squared. Yep, that's right. It's secant squared y prime. Right? Secant squared y. You're like, sure. Yeah, sounds good. All right, now how do we take the derivative of this guy? This is x plus 5 to the 1/2. Bring the 1/2 down. And then subtract 1 off. And then chain rule would just be to multiply it by the derivative of x, which is 1. So if you forgot chain rule, you would have been okay. All right, let's fix this. So then I have y prime equals. Now all of this stuff is going to be on the bottom. Did you see that? All of it. It's 1 over 2 times the square root of x plus 5 times secant squared y. Because that's divided by the secant squared y. That would be on the bottom also. All right, now we have to set up our triangle because we have to replace the secant squared y. Okay, so here's our triangle. And we'll call this y. And then what do we have? We have that tangent of y is the square root of x plus 5. So tangent is TOA. So opposite would be rad x plus 5. Adjacent is 1. Now we have to find out what this side is. Okay? So this is going to be, a squared plus b squared equals c squared. So this would just be the square root of x plus 6. Okay? All right. So now let's find out what secant squared y is. Remember, secant squared y is the secant of y squared. So what is the secant of y? 1 over cosine. So cosine is adjacent over hypotenuse. So this is going to be hypotenuse over adjacent. So it's the square root of x plus 6, but squared. X plus 6. Okay, and then we're ready to plug it all back in. Y prime equals 1 over 2 times x plus 6 times the square root of x plus 5. I just rewrote it in a different order. That would be it. Nuh-uh, doesn't matter what order. Okay, so all of your answers for these inverse trig functions have to be just in x. There's that little extra step of doing some trigonometry that you're not used to doing, right? You haven't done that in a while. Do you hate these so much? Good. Okay, number 3. You're tired?
How many numbers are there?
This is really it. I only had 3 examples to do.
I didn't know if I should go on.
All right, y equals cosecant inverse of 7x. Cosecant inverse of 7x. All right, let's go ahead and cosecant both sides. Cosecant y equals 7x. All right, who remembers what the derivative of cosecant is? Negative cosecant cotangent? Yeah. Did you hear that? So the derivative of cosecant y is negative cosecant y cotangent y, and then what? Y prime equals 7. So y prime will be negative 7 over cosecant y cotangent y. Yeah, I just put the negative up top. Either way. Okay, so now let's find out what our triangle says about what cosecant y and cotangent y is. All right, you always want to look at this step right here to tell you how to set up your triangle, okay? So cosecant y is 7x. Now cosecant is what? It's 1 over sine.
Which is hypotenuse over opposite.
Cosecant, so sine, so opposite over, it's hypotenuse over opposite, right? So it's going to be hypotenuse negative 7x, and 1 there. All right, so now let's do the Pythagorean Theorem. We'll just call that A. So you have a squared plus b squared equals c squared. So A would be the square root of 1 minus 49x squared. Don't ever tell me that that's 1 minus 7x. That's wrong. Is that right? No. I had it mixed up, huh? All right, let me try that again. Look at it. It's like it was never there. All right, it's 49x squared minus 1. There we go. Okay. I saw some of it looks on your face. Like sometimes I don't know I make a mistake until I look out there and you're like, you want to say something, but you're not sure if you're right or if I'm right. I know. Okay, so now let's go ahead and fix it all. Here we go. So y prime equals -7. What would cosecant, so this right here is the square root of 49x squared minus 1. Cosecant of y would be what?
7x.
Oh, yeah, we already know what cosecant of y is, huh? We have that already, don't we? So yeah, so cosecant of y is 7x over 1, so 7x. And then this would be cotangent. What's cotangent then?
Tangents opposite over adjacent, so adjacent over opposite.
Adjacent over opposite, good. So then that would be the square root of 49x squared minus 1. And then all you have to do is one last little step, which would be -1, because the 7's will reduce, x square root of 49x squared minus 1. They want you to put absolute value around this x right here. You don't have to, though. Okay, I would accept that answer without the absolute value, but the book will have that, so if you see it, just don't worry about it. When you're taking the cosecant of this, they're assuming that that's positive, and it's part of the formula, too. Like if you were to see the formula, it's always the absolute value of that, so that it stays negative. It's a negative over a positive then. All right, well, it's a lot of